So, have you ever asked an AI a question, gotten this brilliantly written, super confident answer back, and then realized it was completely unequivocally made up? Yeah, me too. It's incredibly frustrating, right? This is the absolute elephant in the room with artificial intelligence right now, hallucinations. But what if the ultimate cure for AI making things up isn't actually a better AI model? What if the cure is a smarter search engine? Today, we're going to completely reframe the humble search engine. We're going to look at it as the ultimate real-time fact-checker for the AI era.
Welcome to This Explainer. Today, we are unpacking the absolute cutting edge of information retrieval. We're diving deep into Chapter 15 of the phenomenal book, AI-Powered Search. We're going to see exactly how massive large language models and entirely new search paradigms are colliding, and how they're changing the way we interact with data forever. It's fascinating stuff.
All right, let's jump right in. We've got 5 main stops on our journey today. First, foundation models explained. Second, generative search and RAG. Third, synthetic data and evaluation. Fourth, multimodal and hybrid search. And finally, number 5, the agent-based frontier.
Okay, Section 1, Foundation Models Explained. Because to truly grasp where search is heading, we really have to lay the groundwork first and establish our building blocks.
So, what exactly is a foundation model? Well, it's pretty much exactly what it sounds like. It is a massive pre-trained neural network, often trained on a really significant chunk of the entire internet, and it serves as this highly adaptable base for all sorts of downstream tasks. But here is the absolutely critical thing you have to remember. While these models are brilliant at compressing human knowledge, it is a lossy compression. They do not store a neat little database of facts. What they actually store are statistical probabilities of language. And that lossy compression, that is the root cause of why they hallucinate. When they give you an answer, they're essentially just guessing what word should come next based on vast patterns. They aren't retrieving a saved document.
Now, to actually get the most out of these models, we basically interact with them in 3 distinct ways. Think of it like a student's educational journey. The first phase, training, is like their 18-year baseline education. It takes years, costs literally millions of dollars in compute, and builds their broad general knowledge. Then you have fine-tuning. That's like sending that same student to a specialized college accounting course. It takes a bit of extra time and some specific data, but it adapts their broad knowledge to a really specific domain. And finally, prompting. Prompting is like whispering highly specific instructions to that student right before they take a test. It's super agile, it happens completely on the fly, and it guides their existing knowledge to solve the exact problem right in front of them.
Moving right along to Section 2, generative search and RAG. Let's see how all this foundation model theory builds into real-world applications.
We are honestly living through a massive shift right now. Think about traditional search for a second, the classic 10 blue links, where the engine essentially just points you to a source and says, "Here, you go read it." That's the old way. Now we are entering the generative era. We're moving from simply extracting an answer from a pre-existing text to actually summarizing multiple results at once to what's called abstractive question answering. That is where the AI synthesizes an entirely new, perfectly readable answer based on a bunch of search results. And ultimately, we reach pure new content generation. The search engine is no longer just playing librarian, it's practically becoming your personal researcher and writer.
But hey, remember those hallucinations we talked about? This is exactly where RAG, or Retrieval Augmented Generation, sweeps in and saves the day. RAG is practically the cure for hallucinations, and it does it in 3 incredibly simple steps. First, when you ask a question, the search engine part of the system runs out and retrieves highly relevant, verified, factual documents. Second, it takes those specific documents and essentially force-feeds them to the language model as its factual context. Third, the language model uses its incredible reasoning skills to summarize that provided text into a perfect answer, complete with actual citations. So the AI isn't relying on its fuzzy, lossy memory anymore, it's taking an open book test and the search engine provided the textbook.
All right, Section 3, synthetic data and evaluation. Because look, if we are going to rely on AI to generate our answers and write summaries, we enter a really tricky diagnostic phase. Subjective outputs desperately require objective evaluation. Because making things up is such a major problem, the industry had to create standardized benchmarks to objectively grade these models on their common sense inference and their multitask accuracy. You've got tests like ARC, which measures grade school level science reasoning. You've got MMLU, which is this massive test that handles multitask accuracy across complex subjects like law and math. Then there's Truthful QA, which specifically probes to see if a model is going to just repeat common debunked human misconceptions. And then there is my personal favorite, HelloSwag.
Let's think about how HelloSwag actually works in practice, because it's pretty clever. It gives the AI a context, say a paragraph of instructions about catching dragonflies with a net, and then it asks the AI to pick the most logical ending to that paragraph. It basically tests whether the AI grasps basic physical realities and everyday common sense. So the correct choice in this scenario involves choosing a dark, colored net simply because it's harder for the insect to see. Now, that is a wildly simple deduction for a human being, but it is an absolutely fantastic way to prove whether an AI actually understands how the physical world works or if it's just parroting words. And all of these standardized benchmark tests, they don't just exist in a vacuum. They populate highly competitive platforms like the Hugging Face Open LLM Leaderboard. This is incredible because it gives data scientists and developers a clear, totally objective map of which models to choose for their specific projects. You don't have to just guess if a new model is smart. You just jump on the leaderboard, check its MMLU or Truthful QA score, and see exactly how it stacks up against the competition.
But here's a really cool twist. Evaluation isn't the only thing we use these foundation models for behind the scenes. We can actually use them to generate synthetic training data for our search engines. Imagine taking a document, handing it to an AI, and prompting it with, "Come up with realistic queries associated with this document." The AI can automatically generate thousands of highly relevant query document pairs in seconds. This creates an automated synthetic feedback loop that trains our relevance models without us having to wait for humans to slowly type things in and click around. It is literally AI training AI, and it is a massive time saver.
Okay, moving to Section 4, Multimodal and Hybrid Search. Now that we've really explored how these models handle text, we've got to broaden our horizons. The future of search is way beyond just a simple little text box. To really get this, we have to contrast two fundamentally different ways of searching. Traditional lexical search is purely about keyword matching. If you type the word shoes, the system literally looks for the letters S, H, O, E, S. But dense vector search, that is an entirely different beast. It uses AI embeddings to plot the actual meaning of your query on a massive multi-dimensional map. So if you search for footwear for a rocky beach, vector search understands your semantic intent. It might return sturdy water sandals, even if the words don't match your query at all. And it gets crazier. Vector search isn't limited to text. By using models like CLIP, you can map images, audio, and video into that exact same vector space. This means you can seamlessly perform mind-blowing tasks like text-to-image or even image-to-image searches.
But here is the secret sauce. In the real world, you actually need both. Lexical search is unbeatable if you're looking up a highly specific part number or an exact proper name. Meanwhile, vector search is phenomenal for broad conceptual questions. So the crucial point is how you combine them, and that is where reciprocal rank fusion, or RRF, comes into play. RRF is this brilliant mathematical algorithm that takes the ranked results from your keyword search, grabs the ranked results from your semantic vector search, and seamlessly fuses them together into one ultimate hybrid master list. It literally gives you the absolute best of both worlds.
Finally, Section 5, the Agent-Based Frontier. This is where things get genuinely wild, because we are moving far beyond just finding lists of documents. You see, agent-based search acts less like a traditional query box and way more like a human research assistant. When an agent receives a highly complex prompt, it doesn't just fire off one search and call it a day. First, it logically breaks your prompt down into smaller, manageable subtasks. Then, it runs multiple independent searches, retrieves the data, and actually stops to reason about what it just found. If it realizes, oh wait, I'm missing a key piece of information here, it will literally write a brand new query itself, search again, combine that new data with the old data, and finally synthesize a complete, highly intelligent action or answer for you. It is reasoning in a continuous loop, and it's a total game changer. Which brings us to our final thought for today. As generative AI becomes more advanced, more conversational, and much more autonomous, it is going to desperately need a constant, real-time feed of factual truth so it can operate without hallucinating. So the question is, will search engines cease to be just simple tools for humans and instead become the indispensable, real-time backbone of knowledge for all artificial intelligence? It's a massively provocative question, but based on the incredible systems we've explored today, I'd say the answer is a resounding yes. Thank you so much for exploring the frontier of AI-powered search with me, and I'll catch you in the next one.